Good afternoon, everyone. Today I'm going to discuss some key points regarding radius of atom, radius of nucleus. So, radius of atom have value approximately equal to 10 raised to power minus 10 meter, or you can write it as 10 raised to power minus 8 centimeter, and radius of nucleus have approximate value 10 raised to power minus 15 meter, or you can write it as 10 raised to power minus 13 centimeter, and volume of atom is equal to 4 by 3 pi r cube. It's 4 by 3 pi r cube. And radius of nucleus, you can find out if mass number is given. It's having formula r naught a 1 by 3, where a is mass number and this r naught is a constant, which is equal to radius of nucleus is equal to 1.4 Fermi, and 1 Fermi is equal to 10 raised to power minus 15 meter. So its value comes out to be 1.4 into 10 raised to power minus 15 meter. That is, radius of nucleus is equal to 1.4 into 10 raised to power minus 15 meter. Now I have written here one question. Calculate radius of nucleus of an element having A, that is its mass number, equal to 125. So we'll solve this question, that radius of nucleus is equal to r naught a 1 by 3, which is equal to 1.4 into 10 raised to power minus 15 into 125 1 by 3. So when we'll solve it, it comes out to be 1.5 into 5, which is equal to 70 Fermi, or you can find its density of nucleus. It comes out to be 10 raised to power 14 gram per centimeter cube, or you can write it as 10 raised to power 11 kilogram per centimeter cube. It's an important question where you have to find out radius of nucleus by this formula r naught a 1 by 3. Now we'll start with EMR, that is electromagnetic radiations. Electromagnetic radiations. As its name indicates, these are those type of radiations which consisted of electric field as well as magnetic field oscillating. You can see they both fields, they are oscillating perpendicular to one another as well as to perpendicular to the direction of wave propagation. Suppose I am having 3 pens, one pen in x-axis. Suppose in x-axis electric field I have taken, and along y-axis this one is the magnetic field, then these waves are traveling in the direction of z-axis. So it means these both are perpendicular to one another, that is electric field and magnetic field. They both are at 90 degree to one another, both are perpendicular to one another, and this one is the direction of wave which is traveling, that is energy that in the that is perpendicular to both of them, that is in z-axis. So this is 3D representation of EMR, that is electromagnetic wave. I have tried to shown here in this manner also. Suppose this one is moving like this zigzag manner, it is moving like this, and then another is moving in this manner in which snake is traveling. So these both are perpendicular to one another, and this I have shown you, that is this is the source of radiation, and this straight line, it is the direction of energy, and this one is the electric field applied, and this one is magnetic field which is perpendicular. So in short, they are those rays in which electric and magnetic, as their name indicate, electromagnetic means electric and magnetic field are perpendicular to one another, as well as to the direction of propagation of wave. So mobile radiations, they are also called as electromagnetic radiations, and microwaves also works on electromagnetic radiations. If you will keep samosa in microwave to warm it, then you see that, and set up that microwave to heat up, you will see that samosa is hot from inside and not from outside, because microwaves, they have characteristics that only water absorb. Microwaves, those in which these substances in which water is not present, they will not heat up. Or intensity, you can say, is equal to E naught and B naught, where I is intensity, this one is intensity, and this E naught is maximum electric field, its maximum electric field, and B naught is maximum magnetic field. MF is magnetic field, or in short you can say that intensity is directly proportional to electric field into magnetic field, or you can say that intensity is directly proportional to square of amplitude. That what is amplitude, that will do later on, that under the characteristics of electromagnetic radiations. So intensity is equal to product of electric field into magnetic field, and intensity is directly proportional to square of amplitude. Now we'll do characteristics of AMR, that is electromagnetic radiations. What are its characteristics? First is wavelength. First one is wavelength, which is represented by lambda, LAMBDA, lambda. That is, what is this wavelength? Suppose this is the source of wave from where wave generated, and this one is the wave which is traveling. This one is wave, and this height, you can say, this one is the mountain, and this is called as crest, 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 and this depth of wave is called as trough, TROUGH, and it is rest, C लगा लो उससे पहले, that is crest, and this one is the source of that wave. So now what is wavelength? That height of wave, crest, and its depth is trough, means gadde, trough, and mountains, crest. Now the distance between two consecutive crest, or the distance between two consecutive trough, that is measured by wavelength, that is its wavelength lambda. Now what are its units? Its different units are there. It can be measured in centimeter, in meter, in nanometer, in angstrom, in picometer, in micron meter. See, these all are units of wavelength. That is, 1 meter is equal to 10 raised to power minus 2 centimeter, which is equal to 10 raised to power 6 micron meter, 10 raised to power minus 9 nanometer, 10 raised to power minus 10 angstrom, and 10 raised to power minus 12 picometer. So we can write accordingly which will given to us in statement. And the wave, one complete cycle, that is one complete crust and trough. Suppose this one is one crust, one trough, it means here is one complete cycle. Again this one crust, one trough, this one is crust, this one is trough, here is a second cycle, and so on. Means if you will count here the how many cycles are there, so you can count it's one, it's a two, and it's a two and a half cycles in this wave. So this way you can count. Or otherwise, what do you mean by frequency? That is mu. What is frequency? That one complete wave, that is completes how many cycles, one wave completes how many cycles per second is called its frequency. यानी एक सेकंड में ये कितनी cycles बनती हैं wave की, that is called as its frequency. And this height of crust and trough is called as amplitude. It's called as amplitude, which is designated by A. One more very important thing is here, that lambda is inversely proportional to energy. As much as is the wavelength, lesser is the energy. Means that radiations which has higher wavelength, whose energy is small, for example radio waves and microwaves. So this is all about wavelength. Now is the second is frequency, which is represented by nu or also represented by f, but Maxwell has designated it with nu, so we'll represent it with nu. So what is nu? That is number of waves passing through a point, per second is called its frequency. Suppose, for example, I am having this source from where one wave will generate. This one will move from this side and this wave will travel and it reaches here at its source. It starts from this side, that is from source, and travel and reach till point, suppose it's B. In 10 seconds it reaches it at point B in 10 seconds. Now we have to count its number of cycles. So see here, one crust, one trough. Here it completes one cycle, then again crust and trough. Here is another cycle, crust, trough, one more cycle, and it's a half cycle. So how many cycles are it's having? 1, 2, 3 and 3 and a half. And suppose it travels from source to B and it takes 10 seconds. So how we can count frequency? Frequency is equal to number of cycles. It's having 3.5 cycles divided by 10. So it comes out to be 0.35 cycles per second, or you can write it as 0.35 CPS, that is cycles per second, or you can write it as 3.7 Hz, that is hertz. It's one and the same thing. Means if wave is given to you, you have to count its crust and trough, that will give you one complete cycle. Then you have to divide that cycle by total time given, that will give you its frequency. So how much time is given from source to B? That is 10 seconds. And how many cycles are there in this wave? You can count it 1 and 2 and 3 and 3.5. So 3.5 cycles per second divided by 10, that will give you its frequency. And frequency is inversely proportional to lambda, or frequency is equal to mu over It's inversely proportional to 1 over lambda. For any wave, lambda into frequency is equal to constant. Means if lambda increases, frequency decreases. It means they both have inverse relationship with one another. Lambda inversely proportional to nu. Means if wavelength is more, frequency is less, and vice versa. If we have two waves, we can represent it as lambda 1 over lambda 2, that is equal to mu 2 over mu 1. We can represent its relationship like this way also. Whenever we have two quantities, their product is constant, means they will give always a graph in rectangular hyperbola. Suppose we have to draw its graph, that is graph between frequency and wavelength, frequency along y-axis and lambda wavelength along x-axis. So we'll always get a rectangular hyperbola. Please learn in everything, wherever two variables, wherever two quantities product is constant, whenever they will give graph, that will also come in this shape, that is rectangular hyperbola. And if you know frequency, you can find out lambda, and if you know lambda, you can easily find out its frequency from this relationship. For example, if a frequency is given to you, that is 2 into 10 raised to power 10 hertz, and you have to find out lambda, so you can find lambda. For example, if nu is equal to 2 into 10 raised to power 10 hertz or cycles per second, and you have to find out lambda. So on applying formula, that is lambda is equal to c over nu. C is the speed of light, that is 3 into 10 raised to power 8 meter per second, and mu is given to you 2 into 10 raised to power 10 cycles per second. So the second and second will cancel out with one another, and you will get 1.5 into 10 raised to power minus 2 meter. Now this is speed of light, whose value is 3 into 10 raised to power 8, or you can write it as 3 lakh kilometer per 3 lakh kilometer. That's why if we have to call in America, it hardly takes 1 to 2 seconds. It's because of EMR, that electromagnetic rays, electromagnetic waves, they are moving very fast, that is 3 lakh kilometer per minute. And you can see all around us the radio waves are present, and in around you also and around me also, everywhere radio waves are present. And if one set transistors here and set it as 93.5 FM, it will catches a signal and convert it into sound waves, means sound waves are everywhere. Now we'll talk about velocity. That is velocity. EMR travel with the speed of light, that is velocity. We can write it as c also, but we have another formula for it also, that v is equal to lambda into nu. It's very important for numericals. Then next one is mu bar, which is called as wave number, that is wave number. Simple definition, it's written as, that is wave number is reciprocal of lambda. But that's not just a simple definition, will do its technical point definition, that total number of waves present per unit length, means in 1 centimeter length or either in 1 meter length, how many crusts or how many troughs are present. For example, this is again the source of wave, and this is energy traveling in this direction. And suppose waves starts from this side, one crust, trough, crust trough, and it will reaches here. Now we have to count how many number of waves are there. One crust, one trough, it's one crust, one trough, it's a second, then one crust, one trough, here is third, one crust, one trough, it's a fourth, crust, trough, it's a five, and suppose it's 5.5, and distance traveled from here to this is suppose it's 5 meter. Now you have to find out wave number. It is equal to number of waves divided by distance traveled by waves. So how many number of waves we have counted here in complete cycle, that is 5.5, and if you will divide it by distance traveled, that is 5, it will give you value of wave number in meter inverse, because its units are either meter inverse or either centimeter inverse, either angstrom inverse, etc., because it's reciprocal of wave number. It's reciprocal of wavelength. So inverse of wavelength are its units. So again, see, wave number is number of waves traveled divided by distance covered. That is one very technical point to calculate exact value of wave number. Then its relationship with lambda, that is again important for numerical, that mu bar is equal to 1 over lambda, and lambda we know that is C over mu. So mu we can write it as that it is equal to mu over C, means mu bar is directly proportional to frequency, means as more is the wave number, more is frequency. It means if wave number is maximum, then it will give you lambda minimum, because it's having inverse relation, but as it's direct relation with frequency, then frequency comes out to be maximum. Frequency comes out to be maximum, and opposite to it, if wave number is minimum, then lambda comes out to be maximum and frequency comes out to be minimum, because right now we have done, they both have direct relation and lambda have inverse relation with wave number. So these are very significant things. Now next we'll talk about amplitude. That is amplitude, it's designated by A. That is again it's a source of wave traveled, and this one, that is the height of crust or height of trough, is called by A, that is amplitude, or displacement from mean position is called amplitude, because the source of wave is here and now it displaces from its path, so this displacement is called as amplitude. And amplitude is directly proportional to square root of intensity. It's again very important formula, that amplitude is directly proportional to under root of intensity. And now is intensity. Intensity means energy per unit area in per unit time, that is called as intensity. That is number of photons per unit area in unit time is called its intensity, or intensity is directly proportional to square of amplitude, or it's directly proportional to energy. Now we'll do one question here. Question is a source of sound whose velocity is 330 meter per second produces waves in the frequency range 500 Hz to 6600 Hz. You have to find the wavelength of sound produced. So Here velocity is given, that is 330 meter per second. We have to find out wavelength range, that is lambda maximum is equal to velocity over mu minimum. So it is velocity is 330 meter per second and mu minimum frequency given is 500 hertz. So it is 500. We'll solve it. It comes out to be 0.66 meter. Similarly, lambda minimum will find out, that is V over mu maximum. It comes out to be 330 over 6600. So it comes out 21 by 20. It means it comes out 0.05 meter. So range of wavelength that comes out is from 0.05 to 0.66 meter. It's a very important question. So what they have given you in this numerical, they have given you that a source of sound whose velocity is 330 meter per second produces waves in the frequency range 500 hertz to 6600 hertz. You have to find out the wavelength range, means they have given you two frequency values. You have to find out the wavelength range. So here its velocity is 330 meter. Lambda maximum, you can find out that velocity over mu minimum. Velocity is 330 and frequency minimum range, it starts from 500 to 6600. So here we'll write frequency minimum is 500. We'll solve it. It comes out to be 0.66 meter. Similarly, second lambda minimum will find out V over mu maximum, because they both have inverse relation with one another. So 330 divided by 6600, it will give us value 0.05. So we can find out lambda, that is wavelength range of sound waves, is between 0.05 to 0.66 meter. Thank you. Have a nice day. Bye-bye.